Today's presentation is going to be slightly different. I'm not going to be talking about a lot of computational data, but what I will be talking about is the need for us to kind of set specific parameters for assessing low carbon buildings. And this work was done by one of my postgraduate students who's an architect, so this is mainly done for kind of an architecture-based audience. And the reason for this is to kind of try and present information in terms of building costs and carbon. We talk about carbon, but the biggest cost for large housing associations, asset managers, universities is the cost of running buildings. That's going to be phenomenal. And we tend to talk a lot about zero carbon, and in my opinion, getting zero carbon is very, very hard, achieving zero carbon. So, and the best way to tackle it is to actually take a very low carbon building and try and set some parameters for monitoring where energy is used and how you can reduce it in that sense. So, what's the requirements for a passive house? Some people might be from a German or Austrian audience here, and they will be familiar with this. So this standard, I'll be talking about this standard, then I'll be sort of talking about the research. Passive house is a voluntary ultra low standard for housing, and as you can see here, it relies very much on a very, very airtight building with typically the thickness of the walls is around 30 centimeters, and it relies on this principle of building physics rather than just normal building regulations to achieve this. So you're talking about a very, very airtight envelope, and that almost requires very little heating. So, excuse me. So the idea is, as you can see here, it's got also, because it's such an airtight building, you can't just rely on opening windows, you have to rely on mechanical ventilation for keeping this kind of effectively functional from a point of view. So what does the some of the priorities for a passive house? So much tighter standards, typically 5 times better than building codes on a UK perspective anyway. So we just looked at the previous, for example, slide where that was a very similar kind of house typology to, say, Ireland, to the UK, but it's going to be also applied to Northern Europe. Less than 15 kilowatts per square meter, much lower than building codes. Some houses in the UK are up to 100 kilowatts per square meter per annum, so much higher consumption levels. The air tightness is about 0.6 cubic meters per hour at 50 Pascal versus 5 for the UK regulations. So 5 for the UK. I air pressure tested my house, which is a 1950s house, and it came to about 20. So with all this, you can see there's a lot of air movement, air leakage, infiltration, which causes discomfort. Discomfort isn't always about kind of having thick walls. It's about infiltration. It's about heat loss. So to achieve this, to give you an idea what 0.6 air changes per hour is, it's almost the heat loss for the entire house can be the size of a kind of €2 coin. So that's how airtight these buildings are. As you can see, there will be issues with maybe odors or stale air and so on. That's why you need mechanical systems. There's also this issue of thermal bridges, and what I mean by thermal bridges is not only it's the glazing type, but if we go back a slide, so you can see here the areas around the windows, you have to actually calculate the heat loss going through that. So it's a very, I don't like to use this word nerdy system, but it's a very, very, very specific system of how you can achieve that. So the question is, if this is such a great voluntary system, why don't we build all our buildings to passive house standards, especially in a period when gas prices are increasing? You can typically heat a building. Well, some of these buildings could be heated for 10–20% of the annual running cost of a standard building. So there are issues with these buildings, particularly from the comfort point of view and usability. Clearly, in sort of Northern Europe or most European countries, we get big fluctuations in temperature. The modeling system these buildings use for modeling it is called BHPP, Passive House Planning Package, which relies on maybe different kind of building physics operations and so on to normal standard regulations. So when we look at this, we have sort of passive house has become voluntary, as it is. It's a voluntary standard. Despite sort of support for low carbon buildings, it's not a requirement. And I think a very important aspect here from a UK context there's been a drive for renewable energy. So let's have sort of maybe heat pumps or solar PV or wind turbines. Now in reality, renewable energy isn't the same as energy efficiency. You can put more sort of equipment on a building, bring it to zero carbon, but the building might not be energy efficient. So the study focused on exploring residents in the UK in passive house development. Now globally, I don't think there's more than maybe 15,000 homes or houses or buildings that are passive house. But we tried to use we tried to identify 3 major urban areas where passive house has been developed for social housing. This is not a study based on people who are very, very strong environmentalists who build their own bespoke housing. This is for sort of large, small scale developments. So we went around doing a POE, a post-occupancy evaluation, because the analogy behind the passive house technical system is once you build it, it's perfect. It's got low heat loss, so we don't need to do anything. But we went around and we tried to ask people what are their perceptions, are there any issues that they're not happy with. And the work I'll be presenting today is what kind of automation or digitalization of this work or machine learning can we add to improve these buildings. So what were the findings? To give you a quick summary, residents report high comfort during the winter, so really, really comfortable, autumn and spring, but lower satisfaction in the summer months. So in the summer months, there tends to be overheating. Continuous improvement, the findings suggest that sort of passive house residents need to evolve to address year-round occupant comfort. So the design shouldn't be just focused on achieving an airtight standard. It should be also focused on what residents want. Digital solutions, we propose a kind of a sort of a BIM-based approach. We see a lot of sort of mentioning of smart buildings and why smart buildings are important, but there hasn't been a lot of analysis on what elements should we monitor. You can put endless monitoring devices in buildings, but ultimately what you're going to do with this data, how can it help residents? You can monitor CO2, you can monitor kind of temperatures, but ultimately how is this driven? Is it driven by just the designer? Is it driven by the occupants and what they think? And so on. So we went around these properties, we sort of surveyed them. I'm not going to present all the results here, but I'm just going to present some snapshot. So based on the POE toolkit, we presented sort of the questionnaires and we asked people what they think, and that was the best way. So, knocking on doors and asking people what they think of their specific homes. It was collected sort of 3 or 4 years ago, this data, but it took us a while. So in all, we've got about 4950 POEs, post-occupancy evaluations. And we use sort of SPSS planning packages. We looked at variables, and we tried to sort of put this in perspective of thermal comfort and behavioral change, living standards improvement, and overall satisfaction. Because ultimately, this standard is about thermal comfort. And if I ask you, can you put a price on your thermal comfort and your family's thermal comfort? There isn't a financial limit to this. You want to be comfortable, you want your family to be safe, and you want them to sort of live in a very comfortable environment. So the 3 case studies that we looked at, I'm not going to go through them in detail, but this is Forge Bank co-housing, so it's a co-housing sort of development. We looked at the Racecourse, which is in the northeast of England, and we looked at the Goldsmith Street, which is the newest development in the UK, and this won the RIBA prize for the best passive house development. So even the sort of big professional bodies are thinking, well, passive house is something I should be taking notice of. So this is the largest passive house development, and it's sort of designed to address social housing and eliminating fuel poverty. Fuel poverty is a big issue in the UK, and fuel poverty is defined as if you spend more than 10 or 15% of your annual income on heating costs, you are in that category. And if you think the housing stock in the UK is one of the oldest in Europe, we have huge issues, just like in Ireland you heard earlier, huge issues with regards to retrofitting. So you can see, so this is sort of some snapshot of the data, post-occupancy comfort, and you can see here we asked people out of 100, like a percentage in terms of 100, how satisfied are you, how dissatisfied are you throughout the day, mornings, evenings, dependent on the need, never dissatisfied. So even within this passive house type of standard, depending on the housing type and depending on the housing design and the orientation of the windows, there's still a variation in terms of thermal comfort. And normally when these houses are designed, they're just handed over, and with a mechanical ventilation heat recovery system, yes, there is a limit to openable windows, but you can't kind of fully open the windows because then you'll increase the heat loss. So it is almost like a very rigid system. It's a very controlled system. So what's the solution to this? I mean, people, yeah, I mean, I'm sure if you've shared an office with what people, some people feel cold, some people feel warm, but how can you address this? Unless somebody has their own personal heater next to them, there's a lot of things that you have to address. So some people experienced discomfort more than others, maybe in the second kind of case study and so on. In terms of comparison of winter and winter sort of housing and sort of different studies, there's also been an evaluation there. So, excuse me. So central heating, MVHR, windows. Can the windows be openable? There's also a variation within that. Some people had to use a portable heater or a portable cooler to compensate for certain discomfort levels and so on. Because in the summer, a passive house can get quite warm. And your mechanical ventilation heating system isn't working as effectively as it would in the winter. So the results were quite varied across these three case studies. And when it came to asking people why they chose this standard, why they chose a residents' perception of passive house features across the case studies, in a way, sustainability wasn't the main driver. They loved the house type. They like the house price. House prices are a big factor in the UK. Sustainability was important, but it wasn't the major thing. With the co-housing, this community aspect is important. So you have a shared space and so on, which actually presented a very, very good kind of rationale for some people buying it. But you can see these things were quite varied across the different house types. Again, so what's the solution to this? So ideally, should we be offering a kind of a dynamic machine-based learning system? Should we be giving users of passive house more feedback? Because ultimately, these systems are designed for central heating, boiler, heat pump, but with a passive house, you almost don't need any additional heating. It'll just rely on internal heat gains. So internal heat gains could be important. So do we need dynamic solutions from users rather than fabric-based? We tend to always be obsessed with controlling all the heat losses and designing the windows so they're smaller on the north side rather than the south side. But is there an element of kind of digitalization behind it? So this is what my sort of concept I'm trying to present today is what sort of these types of buildings, in order to sort of destroy any myths around why they're not usable, because a lot of architects or designers will say, well, these are hard to achieve, they'll cost more money, they'll promote stale air, but actually in reality these are the best buildings to promote zero carbon, and because they're already, the energy consumption is quite low. So rather than taking a heavily glazed museum building and trying to monitor it, you might as well start with a very, very low carbon building. So this was the kind of model we tried to propose is you can use this, because passive house currently just relies on building physics, fabric first approach, but an intelligent BIM-based post-occupancy model might be the best thing for this, and it doesn't have to be very, very complex, and it could rely on the building type, the typology, the orientation, and it could rely on things such as the ventilation. It could also, so these are the kind of 6 or 7 categories we decided upon. The other thing is we sort of decided on user data and input, age and age, kind of occupancy. The problem with this type of sort of new fabric-based approaches in the UK, we're used to turning the heating systems on, and we can feel very hot radiators, and if you don't sort of feel the heat, you have a sense of discomfort. What's going on? I am warm, but I don't feel the heat. So you can into a model you can actually put in age group, age sort of activity type, and so on, and this can actually help you maybe set temperature parameters. It can help you set kind of thermal comfort levels and so on. rather than thinking, well, actually my house is cold or I can't open the window. So I think this is kind of the best approach is if we combine this very, very fabric-based approach with the user type, with the sort of 6 or 7 elements in terms of air quality and so on. And even cost doesn't have to be an issue, because if you design your passive house building in the right way, it doesn't have to cost more. So you can see that these results that we obtained, while they gave us a very good post-occupancy evaluation, it's very important to try and address this in a wider perspective. So looking back to going back to sort of findings, I think you've covered this before. Results sort of align with the methodology of what the passive house does, but in terms of usability, there's issues that we have to address. But the result does emphasize that there's a lack of long-term post-occupancy evaluation and longitudinal studies. So I think that's the stuff that we need to focus on is ultra-low carbon buildings need to sort of have some kind of machine learning digitalization behind them. You can't just rely on the fabric-based approach. And that's really it. I would like to sort of, I'm happy to collaborate with people around carbon counting, digitalization, embodied carbon. I'm very passionate about this subject. I try to retrofit my house. There's an Instagram channel on how this is done using ultra-low carbon. So if anybody wants to follow it, I'm more than happy to do that. Partly my daughter tells me if I'm on TikTok, I'll be more popular, but I'm too old for that. Thank you.